Today we're going to be learning about another kind of graph that shows an object's motion, this time a velocity time graph. So first up, we need to learn some vocabulary. How fast something is moving is called its speed. This you're probably already familiar with. The new word that we've said a little bit this unit, but is velocity. So when you include a direction with speed, we just call it velocity in physics. So if you say something is moving 10 miles per hour to the left, then that's a velocity. We will be using like meters per second. So if you say something is moving at 5 meters per second to the right, that's a velocity. If we just say it's moving 5 meters per second, it is a speed. We can tell an object's velocity from the slope of the position time graph. So we'll talk a little bit more about that. Remember, on position time graphs, if we want to know if something's moving to the right, we tell that from the slope. If the slope is positive, if the line is going up, we know it's moving to the right. When something's moving to the left, then we just have a negative slope, so the line is going down. If something is not moving, then it has a zero slope or a flat line. When we want to see where an object starts, remember that is the y-intercept of a position time graph. And lastly, if we want to know if something is going fast, we just look at the steepness of the slope. So steeper lines mean faster. So we are going to use that information to make some new graphs. These new graphs are just velocity time graphs, and it shows you an object's velocity instead of its position during its motion. So usually we'll be doing these side by side with position time graphs. The velocity time graph basically just shows you which way is something going and how fast is it moving. So if we look at this position time graph, we know that one. It's a line that's going up, so it's moving right, and then it's not very steep, so that means it's going slowly. That velocity time graph would just look like this. And we'll talk more about how to make that in a second. This is just as an example. If we have the second object, so we know this blue one is moving to the left quickly because it has a steep slope that is going down, or a negative slope. That velocity time graph would just look like that. So on a velocity time graph, if we want to tell the direction of motion, we can tell which way it is moving just by where the line is. So if our line is in the positive region, so that means anything above the top half of the graph, the time axis here, so anything up here, it means it's moving to the right. If we have anything down here, it means it's moving to the left. So anything up here is moving right, anything down here is moving left. We can also tell how fast something is going from the velocity time graph by looking at where the line is located relative to zero. So if we have something really far away from zero, that means it's moving fast. If we have something close to zero, that means it's moving slowly. And if we have something on zero, that means it's not moving. And all of these are moving to the right, or I guess these top two are moving to the right. So this one's going right quickly. This one's going right slowly. This one's not going either direction because it's stopped. The same thing goes for left. So that line close to zero, but in the negatives, that would be going slowly to the left. And this one, the purple one, would be going quickly to the left. So here is where we can practice some of this stuff in your notes. So given this description, you can pause here for a second and write that description down before we move on to the position and velocity time graphs. So if we are going to draw a position time graph like we practiced earlier this week, remember the object starts at position 0. That tells us where our line should start. That tells us our y-intercept. So when it says starts at 0, that means the y-intercept needs to be right down there at the bottom. Then when we see the object is moving to the right, we know that means put a positive slope on our graph. So we just make our line go up, and it has a positive slope because, again, it says the object moves to the right. So now for the new stuff, the velocity time graph, we need to draw a velocity time graph that reflects this information. So here I have an object that is moving kind of like, we'll say at a medium speed, and it is moving to the right. So that means I am going to put my velocity line in the positive region because, again, our object is moving to the right. So notice we have a positive slope here. That means we need a positive velocity. And then it's like medium speed, so that's why we just put it halfway up. If this line was really flat, we'd put it close to 0. If it was really steep, we'd put it way up here. Here's our second example. This time, we are given a position time graph. So again, you can pause the video here for a second, draw that position time graph before you move on. And now we need to write a description. So remember, we start with our starting point on the position time graph. So it starts all the way up here. So we know that means the object starts to the right of 0. Because again, we have a positive y-intercept. So our line is starting somewhere up here. So that means it just starts right of 0, not at 0. Then we have a line with a negative slope, or a line that's moving downwards. So that means the object is moving to the left. On the velocity time graph, if something is moving to the left, we just make a negative line, or a negative value here. So our velocity is in the negative region, again, because our line is going down. So we just have a negative velocity. And same thing as the last one, this is kind of like medium speed, so we just put it in the middle. If it was really flat, we'd put it closer to 0. If it was really steep, we'd put it a lot farther away from 0. So it's just kind of in the middle. Third example. This time we'll go back to a description, but this one is a little more complicated. So if you look at it, we say it starts right of 0 here, and then it stands still, and then it moves left. So there's a couple different things going on. So we want to start with our starting point where it says starts right of 0. So that's how we know the y-intercept is going to be somewhere positive. And then standing still, remember that gets represented by a flat line, and then moving left, a line that goes down. So starting right of position 0, that means we have a positive y-intercept. Standing still gets us this flat part, and then moving left, our line goes down. On a velocity graph, we have two different parts here. So the first half, our line is flat, so that means we're not moving, so we are going to put our velocity at 0. And then for the second half, our line is going down, we have a negative slope, that object is moving left, so we just make a negative line for velocity. Sometimes you'll see these two lines connected with a little vertical line. It doesn't matter if you just do a jump like this or if you connect them with a vertical line. Either is fine. Last one, we have a given velocity time graph. So you can see here we have a top part that's positive, and then it jumps down right away, and the second half is negative. So remember, on a velocity time graph, this top part, it tells us the object moves to the right. And then this bottom part, since it's negative, it tells us that it moves to the left. So I want to draw the line for an object that moves to the right and then moves to the left. Also notice this velocity time graph doesn't give us a starting position at all. So we don't know where the object starts, so we can just start it at 0. So moving to the right, remember on a position time graph, that means the line goes up. It has a positive slope. So this is the moving to the right part. And then moving to the left, that's when our line goes down. And notice both of these are about the same distance away from 0, so we give them about the same slope. So it's not like the second half is way flatter than the first half or anything like that. And then our description. Again, since we're just given a velocity time graph, we don't know for sure where the object starts. If you want in your description, you could say it starts at 0 because that's where we drew it. But we'll just say we know for sure that this object moves to the right and then it moves to the left. Again, since we have a positive velocity for the first half, that's how we know it's moving to the right. And then a negative velocity for the second half, that's how we know it's moving to the left.